Okay, hi and welcome to day one of more factoring. Now, I know I'm not on the first page. We are actually going to skip to page 4 so that we can start doing the graphs and that sort of stuff. And in class, we'll look at the first couple of pages. Graph each of the following polynomial functions. What are the function's zeros? Counting multiplicities. What are the solutions to f of x equals 0? What are the x-intercepts to the graph of the function? How does the degree of the polynomial function compare to the x-intercepts of the graph of the function? So, first thing here we have our zeros. And we've been talking about the zeros from the last unit. So we take each factor, which there are 3, and set them equal to 0. So x equals 0, x minus 1 equals 0, so x equals 1, and x plus 1 equals 0, so x equals negative 1. So my solutions are x equals 0, x equals 1, x equals negative 1, and my x-intercepts are x equals 0, x equals 1, x equals negative 1, because we have said time and time again excuse me, that our zero solutions and x-intercepts are all the same. And then it asks us, how does the degree of the polynomial function compare to the x-intercepts of the graph of the function? Well, this is a third degree. Oh, just a minute. So it's a third degree polynomial. And we have 3 x-intercepts. All right, now we need to graph the functions. Okay, so what I did is I drew my axes in. This is x, this is y, and I have an x-intercept at 0. I have one at positive 1, and then I have another one at negative 1. So now I need to draw what it looks like. So I actually put it into my calculator to kind of help me. And by looking at the picture on my calculator, this is sort of the image I get. And I apologize. It's really hard to draw on these things. And this is f of x equals x times x minus 1 times x plus 1. All right. So let's go ahead and look at B. So my zeros are all x equals negative 3, well, the multiplicity of 4. I think I messed with my lines. I did. Sorry. As I'm looking at that, I can see little arrows on the ends of all my numbers there. Okay, so then my solution is just x equals negative 3. My x-intercept is x equals negative 3. This is a 4th degree polynomial, because if I were to multiply all my first terms together on my x's, I'd get x to the 4th. And the x-intercept, we have one x-intercept, and the degree is larger than the number of x-intercepts. All right, so I'm going to go ahead and draw my graph here. Let's see if I can get this to turn now. Nope. Of course not. All right, so let's get back to this here. So if I'm going to graph this, my only zeros at negative 3, 1, 2, 3. And I have multiplicity of 4. When I have an even multiplicity, it only touches the x-axis. So again, I put it into my graphing calculator just to kind of get an idea of what the picture would look like. And this is what I get. And I can rewrite this as x plus 3 to the 4th power. And then that's the same equation. All right, moving on. All right, for the next problem, f of x equals x minus 1 times x minus 2 plus x plus 3 times x plus 4 times x plus 4. My zeros are x equals 1, x equals 2, x equals 3, x equals 4 with a multiplicity. Oh dear. All right. So now that I've got that all fixed up here, these are my zeros. And then my solutions will be x equals 1, x equals 2, x equals 3, x equals, should be negative 4, and this should be negative 3. My bad. Negative 4, negative 3. My x-intercepts are x equals 1, x equals 2. I'm not having good luck with this thing tonight. It doesn't like me for some reason. Alright, so x equals 1, x equals 2, x equals negative 3, x equals negative 4. Really doesn't like me tonight. X equals negative 4, and these are my x-intercepts here. And then that would make this a 5th degree polynomial. And there are 4 x-intercepts. So the degree is larger than the number of x-intercepts. So I'll graph this picture here. We have intercepts at negative 4, 4, negative 3, and then at 1 and at 2. So again, I use my graphing calculator to help me out. And when I have a multiplicity of an even value, that means I just touch the axis and I don't actually cross it there. So it's going to come up here, touch, turn around, come back down for a little bit, turn right back around, go right back up, come back down, and it's actually going to come down a little further. And that's sort of what it's going to look like, but you're just going to look much nicer because you did it on regular paper. So x minus 1, x minus 2, x plus 3, x plus 4. Whoa. Oh. All right, so then moving on down to the next problem here. My zeros are only going to be x equals 2 and x equals 3 because x squared plus 1 does not give us any real roots because it's plus and it's squared, not a minus. So my solutions are x equals 2 and x equals 3. My x-intercepts are x equals 2, x equals 3. And this would be a 4th degree poly with 2 x-intercepts. Or 2 x-intercepts. So the degree is larger than the number of x-intercepts. So we have 2 and 3. Oh, here's 2. Here's 3 for my x-intercepts. And again, I had to use the graph to help me. And 1, 2, 3, 4, 5. I happen to look this point up. So it kind of comes down. I'm going to go through my points and then around them and back up. So this is f of x equals x squared plus 1, x minus 2, x minus 3. Ugh, that has been a lot of fun with those graphs. Let's actually talk about them. Next page. Consider the function f of x equals x cubed minus 13x squared plus 44x minus 32. Use the fact that x minus 4 is a factor to factor this polynomial. So if x minus 4 is a factor, that means I can use some other form of things like a syntactic division. And I'd have 4 here. And I'd have 1, negative 13, 44, negative 32. So bring down the 1. 4 times 1 is 4. Negative 13 and 4 is negative 9. 4 times negative 9 is negative 36. And then, let's see here. 44 and negative 36 is positive 8. And then 4 times 8 is 32, which means I have a remainder of 0. So I have one factor of x minus 4. The other one is going to be then x squared minus 9x plus 8. And that is actually factorable. So my factors of 8 that add up to 9 are x minus 1, x minus 8. So find the x-intercepts of the graph. So my x-intercepts would be x equals 4, x equals 1, x equals 8. For C, at which x values does the function change from being positive to negative or from negative to positive? Well, every time a graph crosses the x-axis, it changes its y value from positive or negative. So at x equals 4, x equals 1, and x equals 8, it'll change. To sketch the graph of f, we need to consider whether the function is positive or negative in the 4 intervals. So I need to look at a value, and let me just reorder these so that they're in nice numerical order. X equals 1, x equals 4, x equals 8. I need to look at stuff less than 1, between 1 and 4, between 4 and 8, and greater than 8. So we have a couple different ways we can do this. We can substitute into the calculator and get y values to tell us if it's positive or negative. So when we sub in x values, we get y values, which tells us if our function is positive or negative. So how can we tell if the function is positive or negative on an interval between the x-intercepts? Sub in x values. In our interval. Or I like to do a number line. I do one number line for every factor. So we have x minus 1. We have x minus 4. And we have x minus 8. And then we have all three of them put together, because those are my factors. So this is equal to 0 when x is 1. This is equal to 0 when x is 4. This is equal to 0 when x is 8. So I'm going to write down my 1, my 4, and my 8 on my bottom line. And notice I've lined them up as to where I had them up above. So now I'm going to go work up with this one right here, top line. I'm going to ask myself, if I put a number less than 1 into x minus 1, would it be positive or negative? So that would be negative. So I put it in like a 0. If I put a number greater than 1, like 2, so 2 minus 1 is 1, that is positive. And then for the next line, I do the same thing. Put a number in less than 4. My answer is negative. Greater than 4. My answer is positive. Same thing with 8. Less than 8 will give me something negative. Anything greater than 8 will give me positive. So what I do real quick is I kind of draw some squiggly lines down to help me stay organized. And then I multiply my lines because all my factors are being multiplied together. So it doesn't matter what numbers inside the parentheses as long as we have positive or negatives, because that's all we're looking for. So negative times negative times negative is negative. Negative times negative is positive. Positive times positive is negative. All positives is positives. So now we found the intervals for which our function is going to be positive or negative. So let's go on to the next page. And I'm going to redraw my number line. Oops, that's positive 1, positive 4, positive 8, negative, positive, negative, positive. So using this, referring to this chart here, let's answer the rest of our questions. For x is less than 1, the graph is above or below the x-axis. Well, because it's negative less than 1, it would be below the x-axis. So because the x value or values lead to negative y values. So between 1 and 4, our number line is positive. So that means this would be above the x-axis. And that would be because the x values lead to positive. Positive y values. So between 4 and 8, it'll be negative again. So that means it's below the axis because the x values lead to negative y values. And then finally, if it's greater than 8, going back to that top number line, it's positive. So that means it has to be above the x-axis because the x values lead to positive y values. So use the information generated in parts F through I to sketch a graph of F. Well, that's Y. This is X. And now we have to use what we have for our zeros. So we need to go back to, we have 1 at 1, we have 1 at 4, and then we have 1 at 8. And we know that when it is less than 1, it's below the x-axis because my y values are negative. So that means it's coming up. At 1, it changes values, becomes positive, and then it kind of does a little loop because then it changes back to negative, and then changes back to positive. So my graph is above the x-axis, it's positive. When it's below the x-axis, it's negative. Graph y equals f of x on the interval from 0 to 9 using your graphing utility, and compare your sketch with the graph generated by the graphing utility. Well, we have to do this one in class. Remind me to show you that, but the answer is they are similar. All right. Next page and last page. So for the discussion, for any particular polynomial, we can determine how many relative maxima or minimum there are, consider the following polynomial functions in factor form, and their graphs. Maxima or minimum are points that we look for on the graph, and that's when we reach a maximum or minimum. So I lost what I was going to say there. So let's see here. How many relative maximum or turning points? That's what we're looking for, turning points. I knew it would come back to me. So we're looking for turning points every time the graph changes direction. So in each of these here, we have 3 pictures, and we have to find the degree, the number of x-intercepts, the relative minimum maximum, and what observations can we make from this information. So my first one, it is a second-degree polynomial, and the number of x-intercepts I have is 2, And the number of related minimum or maximum, I only changed direction once, so it's 1. So then here, I have 1, 2, 3, so it's a third degree polynomial. And x-intercepts 1, 2, 3 on the graph. And then number of relatives of max-mins. These are my min-maxes when they change direction. And the last one is a 1, 2, 3, fourth degree polynomial. And I have 1, 2, 3, 4 x-intercepts. And I have 1, 2, 3 change of directions. So that's 3. And what observations can we make from this information? That the number of relative min-max is 1 less than the degree of the polynomial. Okay, that's also, or the number of x-intercepts. So the number of relative maximum minimums is 1 less than the degree of the polynomial, or the number of x-intercepts, because x-intercepts is the same thing as the number of zeros. Excuse me. Is it true for every polynomial? Consider the answers below. The first one, the degree of the polynomial is 2. The number of x-intercepts is 0, so that never crosses the x-axis. And what number of relative minimum maximums are there? There's 1. So for the next one, my degree is 3, my x-intercepts is 1, and I have no change in direction, so that's 0. And then here we have a fourth degree. We have 2 zeros, and we have 1 relative minimum. So what can we observe from this one? So previous observations did not hold true. The number of relative min-maxes is at most n minus 1, where n is the degree is at least n plus 1, where n is the number of relative min-maxes. And that, I believe, is everything that we need to know with it. Yeah, that's it. looks pretty good for now. There's a lot of stuff going on in this. We're basically just relating the graphs of the functions to their equations, their x-intercepts, and how many roots they have or the degree of the polynomial. All right, and that is it.